Khalid, I think you can start.
We started?
Yeah, start that.
Okay, all right. Well, hi everyone. Welcome to today's series. This is part of the IBM Developer Series, where you can join our webinars and workshop to expand your developer skills. My name is Khalid Faraj, and I'm a developer advocate at IBM, based in Dubai. And with me, I have my colleague Ridal Pandari, who as well is a developer advocate for IBM in Dubai. And today we'll be showing how we can build a recurrent neural networks using TensorFlow as our main technology. Please, to make sure that we can get started, you need to sign up for your IBM Cloud account, so make sure to register there. We have as well our survey link, so if at any time you feel that you need to leave, please make sure to fill the survey before. It has a couple of 2 questions or 3 questions. It won't take a lot of time, just a couple of 1 minute maximum. This would be really helpful for us. And you also have access to the slides. So before getting started as well, I just want to make sure to give you a brief introduction on Crowdcast, which is the platform where we're hosting this session. Basically, you can go ahead and say whatever you want here in the chat and using this field. You can ask a question using the Ask a Question button. The most important part is the Get Started here. It's an action button. You can click on it. Basically, it will redirect you to these resources that we'll be using in today's session. So just please make sure to go there. It's a GitHub repository. We'll have all those links there, so you can go ahead and check them out. And as well, make sure to follow us by clicking the follow button to keep updated with all of our events. So for today's agenda, we will start first by talking about deep learning. So what exactly is deep learning? We'll move to talk about its main tools and the framework that we use these days to build a deep learning model. Then we're going to talk about recurrent neural networks and long short-term memory, which is a specific kind of deep learning network that we use when we're working in neural networks. And then from there, we're going to talk about TensorFlow, why we go with TensorFlow, and we'll spend the rest of the session focusing on the use case with Mridul. So we'll be doing the hands-on part. And eventually, we would love to share a couple of helpful resources that can be a good benefit for you. So what exactly is deep learning? I'm pretty sure a lot of us here have heard about these big terms, machine learning, AI, and deep learning. And to try to explain it the best way is by visualizing this way. So on the very top, we have AI, artificial intelligence, which, as we know, is a technique that enables machines to imitate and mimic human behavior. But to do that, AI needs the machine learning, which is a subset of an AI technique that uses statistics and mathematics to enable these machines to improve with experience. Now, deep learning is a subset of machine learning, which will make computation of multi-layer neural network feasible and solve much more as well computational situations. So these days being used everywhere in all different kind of industries. To remain the point is that we want to show you that deep learning is a very specific field that we use in machine learning. So there are a lot of tools and frameworks that we use when we want to build deep learning models. You know, a lot of time we don't want to go ahead and build everything from scratch. At the end, instead, we don't want to reinvent the wheel. So what we want to do is to use what we have. And that's why these days we have a lot of different frameworks. The biggest that we have always used are TensorFlow, Keras, and PyTorch, which they have give us some functions that make the process much faster for us. As well, there is scikit-learn, which provides a lot of different algorithms that we can use. And I'm pretty sure for Python people who write some Python code, they use pandas and NumPy to manipulate the data. We have a lot of different things such as, of course, like Spark for big data, and there are many other services. To talk about a bit as well of deep learning and the recurrent neural network, because this is what we'll be focusing on today, recurrent neural network and long short-term memory. This is a kind of a high-level tree, let's say, or architecture of how these are related to each other. So basically, under deep learning architecture or deep learning neural networks, we have supervised learning and unsupervised learning. For those who don't know, supervised is basically where we are training our model by labeling the data. So a very quick example on that will be for training maybe a model that can distinguish a cat from a dog. So in this case, we want to input this data, I want to input these images. I'll be telling my model that this image has a cat and this image has a dog. So here I'm labeling it, and in this case, the model will be able to understand how a cat looks like and how a dog looks like, and that's why it's called supervised. And the unsupervised part, it works by not labeling data, so it's the opposite. Instead, the model will kind of learn by itself. It will start to look for specific patterns, characteristics that it can use to assume what the content is or what you want to predict. And now, of course, in this case, our focus will be more on supervised since we are working with RNN, known as recurrent neural network. As well, there is another famous topic called convolution neural network, but we won't be covering this in today's topic. And under recurrent neural network, we have the long short-term memory, which we'll talk a bit later on it and discuss more about it. But this is just a good way to visualize how we are going to work with these two, the RNN and the long-term memory, how they are related to the deep learning architecture by being under the branch of supervised learning. So to start with, neural networks. Basically, these are multi-layer networks of neurons that we use to classify things or to make predictions. They are actually inspired by our human brain. So that's why we call them neural networks, and we call these nodes that we have as neurons, because they are inspired by our human brain. They are made of different layers, mainly three, which are input, hidden, and output. So input layer is where we have our data, and the hidden layers is where we go ahead and make the processing of this data that we have, and then the output is basically the end result of it. Now, the good thing about your network is that we can easily handle time series data or multi-dimensional data, but there is a couple of tricks that we need to know about. So, for instance, the more the hidden layers, the more the accuracy, that's right, but as well, the more it gets complicated. So in this case, we will require much more resources, and you will need to make sure that you have strong machines that can handle this kind of complexity, that have enough power. But luckily these days we have the cloud, so you can easily put the model on your cloud, and it will handle all of this infrastructure part and all of the heavy part for us. And as well with neural networks, when we work with them, we need to make sure that we have a large amount of data. So we do require a big amount of data, and because of that, it can be a bit expensive to train. And as well with neural networks, they tend to have the black box nature. And what we mean by that is that basically they don't prove, we cannot have an insight on which neuron is doing what exactly on processing the input data that we have. Because so in a sense, we cannot make it traceable. It's hard to trace what's happening exactly. So that's why we cannot understand the exact pattern or have a pure high-level visibility on what exactly is going on. So that's why we call it a black box nature. All we have to do is just to put the data in, the hidden layers will do the work, and then we'll have our final result in the output layers. So this is the general concept of neural networks and how they work. This is a very quick example. So in this case, we have a cat and a dog as our data. We will go there. They will go to the hidden layer, and here the networks will start performing actions and functions on this data to understand the content of them. And for example, for the dog, that would be a dog, and for the cat, it will be a cat. Well, of course, in this case, we'll not be focusing on images or cats and dog. We'll be focusing more on something on the domain of language modeling, which we'll talk later on. So that's why we are going to talk about recurrent neural networks, because it's used a lot in this field. And recurrent neural networks is it's kind of a specified field or specified topic inside the neural network aspect. It's one of the foundation network architecture that has led to another creation of different other architectures in the deep learning aspect. So that's why we can say that RNN basically they have a rich set of architecture, like the long short-term memory, LSTM. And the very unique thing about them is that basically they have connections that are going forward and backward. And why that's special is with the regular neural networks, the connections are only forward. So we have the feed forward concept. We only go to one specific direction. We're always moving forward. But here, because we have this backward concept, this will help RNN to include loops. And that's very special because in this way, they will be able to store the information while processing new input. And that's very useful for storing memory. So when we're working with memory or want to store a specific information to predict something else, we will need sometimes to use what we have currently generated, and we want to use these results somewhere else to be able to predict the future. A very basic example on that will be words or letters. For example, when you're typing these days, autocorrection, your chat, or maybe an email, a lot of time when you're writing an email, you will see that the service that you're using will start giving you suggestions on the next word that you want to add. So basically, this is basically one of the main examples in recurrent neural networks, and this is one of the examples as well in language modeling. So we can predict the next word that we want to add based on this. This is feasible because of the concept of backward, where we are storing these input data somewhere in our neural networks, and we are using this to predict what might occur next. So that's why as well in RNN, we use a lot of sequences. It focus a lot on time series and sequence data, patterns, this kind of stuff, which lead eventually to the concept of maintaining memory of past inputs to predict the next step or the future. So just for example, in here, we can see that we have forward loops like this one and this one, but as well we have backward. So we can go ahead, and from here we're going back to the backward part. So this is what we call a loop. And this is what will help to maintain a memory. And speaking of memory, there is no better way to explain this than to talk about the long short-term memory, the LSTM, which is a specific, so we have now a lot of subfields, and LSTM is a kind of a subfield of RNN. So it's inspired by RNN architecture, and it focuses on memorizing specific data, specific input into cells. We use LSTM in products every day. We have products that we use and that they are using LSTM every day, like smartphones, for example. And the great thing about LSTM is that they have introduced the concept of a memory cell that can contain a value for a short or long time. And that means basically that we don't need to store just the last completed value, but we can as well store the most important one and the one that can help us to predict the next values. And the way it works is by going through a specific flow and that has 3 main gates. So when we're talking about a memory cell, there are 3 gates: the input gate, the output gate, and the forget gate. At input gate, it basically the gate that will help to take the data and to put it into the flow, to put it in a specific, to save it, to put it in the memory. The forget gate is basically to remove this data. That means that we're done with it. We can forget it, we can remove it to put a new data instead. And the output gate is kind of the represent the data that is going to be used in the output part. So a quick example on this, we have our input data, for example, in here, and these are different cells. So let's take, for example, this cell here. This cell will have 3 gates: the forget gate, the input gate, and the output gate. And this is what will help the neuron, or the neural network in this case, to control the information flow from input gate to take the data, to use it in the output gate, or to remove it by going through the forget gate. So this is kind of a very high level of how LSTM works. Now we want to, since we are proceeding to the workshop part, we want to talk about the main technology that we are using, which is TensorFlow. And basically, TensorFlow is an open source library that's primarily used for deep learning application. It also supports traditional machine learning, and it accepts data in multi-dimensional arrays of higher dimension that we call tensors. So basically, in TensorFlow, we have this concept of working on data flow with nodes and edges, because with neural network, we have these neurons that will kind of represent the nodes, and we have their connections with which are the edges. And why we go with TensorFlow, it's because it's an easy model building. It has a robust and reliable machine learning production anywhere, and it supports both CPUs and GPUs, computing device. And we can go ahead from an idea, from research, all the way to production. And the great thing about this is we are using functions and that are already there, that are already provided by TensorFlow. We are just getting these algorithms, we are using them inside our code instead of having to write everything from scratch, which can be very, very time consuming. So that's why we use this kind of open source library. One of the biggest one of them is TensorFlow. Now we want to talk about the workshop use case that we'll be covering. So in today's use case, we're going to apply RNN and LSTM for language modeling. Now, as I said before, language modeling is this topic that addresses a lot of difficulties and issues that we have, in speech recognition services or and machine translation, everything related to languages and to linguistics. So in our case, we're focusing on words. We are going to create our RNN model based on the LSTM. you need to train and benchmark the Penn Treebank dataset. Penn Treebank dataset, it's a dataset that covers all of these data regarding speech and linguistics and words, and it's maintained and created by University of Pennsylvania. So we'll be using this dataset. And what we'll be doing is we want to predict a word or letters from a specific sentence according to a specific context. So for example, I don't know, I have or I have a something. Well, this is a word. We have a sentence that has, for example, 3 words for now. We want to predict the 4th one. So this is kind of how language modeling works. It's very popular or maybe the most important factor when we're talking about natural language understanding. We will see this a bit more in the workshop part. We will be talking about this in much more detail. And to do the workshop use case, we'll be mainly using 3 different technologies: Watson Studio, Jupyter Notebook, and TensorFlow, of course. And Flow basically is very simple. We are going to upload the file that we have from the dataset to Watson Studio. And then from there, we will be using Jupyter Notebook, which will have all the code. We'll be using TensorFlow as well to be able to build this neural network. So with that, I think we can get started. Again, make sure to register for your IBM Cloud account and to check the resources to be able to follow along with the hands-on. You need to click on the GitHub repository, which again is on the button below the screen, the green button that you can see on Crowdcast. So we will get started with that. Mridul, I'm going to switch to you now. The floor is all yours.
Thank you, Khalil. I'll just start. I'll just share the links in the chat, and then we can get started. So, yes. Good morning, good evening, good afternoon, everyone. Thank you so much for joining us today. I hope you're all safe and doing well. And my name is Mridul Bhandari, and I'm a developer advocate based in Dubai. And we're going to take you over through the use case for today, and I'll be conducting the hands-on session for this webinar. So before we get started, I would like you to sign up for an IBM Cloud account, or if you already have an existing IBM Cloud account, you can just log in with that account. So you can go to this link that is I've shared in the chat, that is ibm.biz/rnn-tensorflow, or you could also click on the workshop resources, go to the GitHub repository, and the link is also available in the GitHub repository. And the link for the GitHub repository is also shared in the chat, or you could click on the click to action button on the Crowdcast page, that is which has the title workshop resources. So once you click on that, you could you'll be redirected to the GitHub link, and you can it will take you over through the GitHub repository, and you can create your you can click on the link for the IBM Cloud account and create or log in your existing account. So once you're done logging, you're creating your existing account. Like Khalil is showing on the screen, the link is there in the GitHub repository. So you can just go over there and click on that. And once you click on that, you'll be asked to either log in or create. You could choose either of them, whatever is preferable to you. You do not need to enter your credit card information at any point of time, so you don't need to worry about that. So you won't be charged. And what we're utilizing today is all light services, so there's no charges for the services. So you can click on the link and create your account. You'll have to fill in a few credentials like your name, email ID, and it should take less than a minute to verify for you to receive the verification email. And once you click on the verification email, you can just click on the email, and you can verify account, and you can start logging in. So then you'll be redirected to the IBM Cloud dashboard page. So Khalil, please could you open the IBM Cloud dashboard page for us? Yes. So once you create your account and you come to this dashboard page, which is the IBM Cloud dashboard page, which shows you various fields over here. So as you can see, if you see Khalil's screen, so you can see there's a quick start section which shows you the links for some tutorials or for some services. So you can click on that and try to create those services or experience those services with the help of the tutorials. So you'll have a particular use case which you could build, run, and manage API AI models, or you could try the IBM Cloud Shell. So you'll have links like this, and below that you'll have the resource summary, which has the list of all the resources that have you created in your IBM Cloud account till date. So if you have an existing account, you'll have some resources created. If not, if you're creating a new account, you'll have 0 resources. And there's just some other sections with the news, the latest updates on resources and services offered by IBM Cloud. And you can just have some user access and IBM Cloud status around the globe. And all these details are there on your dashboard, so you can keep yourself up to date or posted with these updates from your IBM Cloud dashboard page. So by now, I hope you have all created your IBM Cloud account. So we can get started by creating the service, which we'll require for today. So the first service we're going to create is Watson Studio. So Khalil is now going to search for Watson Studio in the search bar, and you're going to go. We're going to create a service. So you can go ahead in your search bar and type Watson Studio. Once you click on Watson Studio, under catalog results, you can click on Watson Studio. And once you come to this page, just click on the location, select the location as Dallas, and the plan is light plan. It's a free tier plan, so you do not need to input your credit card information at any point. So once you're done with that, you scroll a bit down. And you can click on the service name and you can edit the service name. So like service name for today could be Watson Studio -RNN. That's what we're focusing on. So we could give the service name something that is related to the use case. So we can just say Watson Studio -RNN. And we also have the resource group. We should just keep it as default. So we can just select the resource group as default. Yes, you could select other locations also, but Dallas is something we made sure there's no maintenance going on right now. So it's just that you don't face any issues while running, because they might sometimes, to update the services, they go under maintenance and you're not able to utilize the services. So you can use other locations other than Dallas, but Dallas is something that is for now we have just checked there's no maintenance going on. It is safe. So you can click on Dallas, and once your resource group is default, and once you're done, you can click on create. So I'll just wait. We'll just give you a few seconds so that you can, wait. You come to this page and you can start entering your information. So I'll just wait for other people also to come on the same page so that we can all get started together. So I'll give a few seconds so you can all wait for the studio service to get created. Until then, I'll just tell you about Watson Studio. So Watson Studio is basically a machine and deep learning service that that tries to infuse AI into your business to drive innovation. And it provides a suite of tools and a collaborative environment for data scientists, developers, and domain experts. So it has various features in which you could utilize, and you could create like Jupyter Notebook, dashboards, or you could upload a data here. So you can just you can just go ahead and click. You can go ahead with the service and try to create your own AI models and utilize various data science service and tools to create your own projects. So we will see how that is done. So we'll just wait for a few more seconds till everyone has created the Watson Studio service, and we'll just give it a few seconds. Yes, you can also click on the workshop resources button on the left under the live stream, and you can follow along at your own pace. So you can, if you're having difficulties keeping up with the pace, or you want to make sure there's something documented, you have everything documented for you. So you can click on the workshop resources, you can go to the link, and all the steps are being documented over there. We have given all the steps with images. So there's a step-by-step guide on how to create your IBM Cloud account and your Watson Studio service. So once you're done with creating your Watson Studio service, you can click on you come on this page, which is shown on the screen right now. So that is Watson Studio -RNN. That's the service name you have given. And you'll see Watson Studio logo, and it says, "Welcome to Watson Studio. Let's get started." And under that, we have the Get Started button, that's the blue button, Get Started. We click on that. So we just wait for the page to open. So we'll just give it a few seconds. So once you come to this page, you can click on maybe later the tutorial, and you can see this. You can see welcome your name. For us, it's welcome Khalil, because this is Khalil's account. And you can see the list of recent projects he has worked on and the notifications from these projects. And there are deployment spaces which he has worked on that has been listed over here. So this is just like the IBM Cloud dashboard. It gives a brief overview of your Watson Studio service. And this this is what we're going to be utilizing today to create our recurrent neural network using Jupyter Notebooks. So you can, I'll just wait for a few seconds and wait for you to open up this page in case it takes time to load. So I see a question in the chat section that says, what is the difference between TensorFlow and PyTorch? So both TensorFlow and PyTorch provide useful libraries to reduce the amounts of, the boilerplate code and we need to type, and it also speeds up the model deployment. So the main difference between them is PyTorch is more Python related, it's more Pythonic, and it has an object-oriented approach, while TensorFlow has several options which you may choose from. So this is the main difference from both between the both. You can go ahead and you can use any of the libraries you prefer. For today's use case, we'll be using TensorFlow. That is something which that is we'll be utilizing for use case today. But if you are looking to experiment, you can also try out PyTorch. It's an amazing library. So you can go ahead and you can try out using your own experience by using PyTorch for the same use case. So by now, I hope you have all created your Watson Studio service and you have come to this page which is shown on the screen with the welcome Khalil page. That is so the welcome page where we see all the projects and the notifications being listed. So now we click on the hamburger menu button on the top left corner, or you could and you can click on projects over there. Or you can also go under, this left hand side down, you have see the projects link. You can just click on that and you can go to this page and you see a list of projects that you have been working on, and they have been all listed over here that has been created. If this is your first time using Watson Studio, then you will have no project created, but no worries, you'll be creating a first project today. So Khalil is going to click on a new project, and once you come to this page, you have to define your details. So you can enter your project name. So we can say recurrent neural network using TensorFlow, or RNN using TensorFlow, any project name which you would like to give. You can give that project name. And you can also enter some description over here, some details about the project which you would like to, give a brief details. You could just write, this is something we're working on, recurrent neural networks using long short-term memory for language modeling. So you can write that something over here if you prefer to. Otherwise, you can just skip over it. It is not compulsory, but you need to enter a name. So that is something that is required. And so on the right hand side, you can see the storage section. So under the storage section, you have the cloud object storage - Khalil listed shown over here. But in case you have been using Watson Studio for the first time and you haven't created an object storage service, it'll give you an option to create one. So you click on that link and it opens up. So once you go click on that link, it opens up a page on. It's similar to Watson Studio, the page which we came across while we are creating a Watson Studio service. So it shows the plan options, that is light, and the location, that is you can choose Dallas, and you can just click on create. I think what object storage service does not have an option to select the locations. You can just click on the plan, and that is light, and you can click on create. Once you're done with that, you come back, you refresh, you'll have the service that is associated with this Watson Studio project, and you can click on create project. So while the page loads when you create the project, so I'll just explain what is object storage service. So object storage service is basically a data storage service that helps you with your cloud native workloads. So it has a built-in high-speed file transfer capabilities, cross-region offerings, and it has a lot of integrated services. So this makes it very easy to transfer data and store your data, and easy for you to access your data and utilize it for various services. So whatever work you're doing today, we want to make sure that it's stored and it is safe. So we'll need to create an object storage service to create everything we'll be doing. So you just need to create that. And again, this service, you do not need to enter your credit card information. You can just go ahead, create the service, and you'll be able to associate with the Watson Studio service. And once you come to the Watson Studio page, you can click on. You can see the overview where you have the project name, the date it was created. Then you have some overview on the date it was created, and the description that Khalil has given. and the storage you're using. So for now, you're using 0 bytes. We haven't started working, so you have nothing. And the collaborators. That is, for now, it is only Khalil's name. But if he was collaborating with other people for this project, he can add collaborators so that they can all access the files and they can all work together. And it is all stored, it's live, so you don't have this fear of losing your work. So you can collaborate with people across different geos, different teams to work on projects. And then you have the recent activity, which shows what's been going on in this project. So you can, see the list of updates that has been going on in this project. And below that, you have the README document option to document your project using the standard Markdown syntax. So this is similar to GitHub. So if you've been utilizing GitHub, you can see there's a readme.me file. This is similar to that. So you can similarly document your entire projects. As I mentioned, you can collaborate with different people. So while you're collaborating with different people, it might be tough to understand, what the project is about and what the work's going on. So you can go ahead and you can create, you can create this service, and you can add this document, and you can document your entire project, the details about your project, and it should help you share your details across different teams, across different collaborators who are working on this project. So once you're done with creating this project and you come on this page, you can click on the assets section, assets. And you click on the asset today, where our main work will be done. So once you come to the asset section, you can click on add to project. You can click on add to project.
Yeah, Middle, we cannot hear you anymore.
Hello.
Yeah, your voice is a bit, there's a kind of an echo. It was better before.
Yeah, I am not. I'll just try to refresh. I try to change the audio settings again and see if that happens. I don't know why that happened. It's probably due to bandwidth issue. I'm really
Try
sorry about it.
refresh.
I'll try to fix it. Just give me a second.
It's very hard to understand exactly what you're saying at the moment. If you can try to refresh or to join again, because try to refresh. Or okay, guys. So we'll wait for Middle to join. But meanwhile, I hope everyone has reached this step. So what we have done, we have created a Watson Studio instance. We've went there. We've created a project by clicking on the create an empty project, and we've assigned a cloud object storage service to it. Which will lead us to this part, the assets one. Basically, assets is where we can add our data or our different resources that want to work. If you want to maybe build a machine learning model or use a Jupyter notebook, this is the place that we use, as we will see right now once Middle will come back. But meanwhile, what will happen is we can proceed while we're waiting for Middle, but you can click on add to project right here, and you will see that we have different assets type. If we want to add a data, sometimes we want to add a connection. If we already have an existing data, we just want to make sure that we can read this data from Watson Studio itself. But in this case, what we're interested in is notebook, since we are working with Jupyter Notebook. So we can go ahead and click on Jupyter Notebook. And in here, what will happen is you can just simply choose the default as it is runtime. We're going with Python 3.7. What we want to do is to get an existing notebook. So it will be a URL, and we will add the URL right here. So if we go back to the GitHub repository, let's go back to here. So this is our GitHub repository. There is a folder called Notebooks. You can simply just click on it. And you will see that this is our notebook right here, the file.ipynb. So we'll click on it. We'll wait till it's load, and we'll go ahead and click on raw, this button right here. So once we're here, we will see that we have this URL. So what we want to do is to copy this URL link that we have and go back to our Watson Studio and paste it in here. Okay, and of course we need to give a name to our notebook. Let's say we'll name this as RNN TensorFlow no, or LTSM language modeling MB for notebook. You can name it whatever you want. You can give it a description if you want. But we'll go ahead and then click on create.
Hello, hello.
Yes, yes, Mridul, now we
Yeah,
can.
Khalil, is my audio better?
Yeah, now it's better. Now it's better.
Yeah, yeah. I'm really sorry about that. So actually, I just refreshed. So Khalil, which step were you on? Which step do I need to repeat?
Yeah, so I was explaining to them how they can create the notebook. So basically what I did so far is that we went to GitHub repo, we took the URL link, and we've added to Watson Studio, to the Jupyter Notebook. So we are importing the URL, and now we're waiting till it's load. So back to you.
Okay. So yeah, so hi everyone. Sorry about that audio issues. So we'll just wait for the notebook to load. Khalil's loading the notebook, so we'll just wait for it to load. It takes some time, so you can take a few extra minutes. We'll just give it a few extra minutes so that you take some time to load the notebook, and we will get started once the notebook is loaded for everyone. Meanwhile, Khalil, can you open the notebook which I had shared with you with the results?
Just to double check, it's that one middle, right?
Yes, I've shared the link, the top one.
Yeah, that's the
Yeah,
okay.
yeah. Can you just scroll down a bit?
Okay.
To see if
Okay, just to double check, yeah.
yeah. Like, can you just go to the cell and see the output is there for the cell? Yeah, I think that is the one.
Okay.
Yep. Yeah.
All right, good.
All right.
Just
Yeah.
let me go back to mute. 1 second.
Yeah.
Yeah, okay.
So I hope I know you have all loaded the notebook and you have all joined you have all loaded the notebook and you have come to this page which shown in Khalil. So you have all loaded the notebook. So Khalil, can you go to the other notebook which we uploaded right now to Watson Studio? Yeah. So once you come over here, you can see this is in the edit mode. So you can see the options like to run, and you can stop, and then you have the option to cut, copy, paste. They're all these icons over here. So you can do these various steps. So this is where we are going to be working today. So let's start over this. We'll start over this. So the thing is, this notebook takes a few hours to run. It takes around 6 to 7 hours to run for because the number of epochs. So you can just run, and the result will be generated later. But what we'll go do today is we will explain the notebook to you. We'll understand the steps so that you're able to understand the notebook, and within a few hours you'll have the results. We also have completed have a notebook which all the results uploaded. So that has been run and it has the results. So we'll share the results with you so you can see how it looks like. And let's proceed ahead. Notebook failed to load. So are you sure you copy pasted the entire link correctly? Because sometimes there's a full stop in the end, or did you miss the extension because there's .ipynb. I hope you have made sure the URL is correct. So what you could do is try refreshing the Watson Studio service, and you can see if the notebook uploads. If it loads. If it fails to load, then there's one more option. So Khalil, can you open the GitHub repository? Yes. Can you go back to the GitHub repository? So the other option we could go ahead with is we could download the repository. So you can see the green button on the top on the repository. There's a green button code. You can click on that. You can download a zip, or you could install it using your terminal if you're familiar with terminal. So you can download it or you can download and install it open with GitHub Desktop. You can just click on download zip, and once you download the zip, you need to unzip the file. Or if you've downloaded with GitHub Desktop, you do not need to unzip the file. Or if you've downloaded using the GitHub CLI, you don't need to install the unzip the file. So once you come in that under notebooks, you'll have the notebook over there. So once you go back to the Watson Studio the page, Watson Studio under assets, Khalid, could you go to the Watson Studio page with the under the assets? Can you open? Yeah. So once you come to this page, you can click on Notebook. No, you click on Add to Project and you click on Notebook. Assets, you go to Add to Project and you click on the Notebook. And you go to the From File option. You go to the From File option and you can drag or drop the file, or you could just click on this and you can go and select the file to upload the notebook. So that's the specific notebook. So once you try that approach, I think that should solve that issue. I'm not sure, there's some issue, some other issue it's not able to load. But yeah, this is another alternative you could use to upload the notebook. So that way you can still upload the notebook. So if anyone else is facing that issue, they could also try this approach. So you can just install the GitHub repository, unzip the file if it's zipped, and then go to Watson Studio again and go to Assets, go to click on Add to Project button, and you click on the Notebook button. And under Notebook, the new Notebook section, you select From File instead of From URL, which you're doing. You can select the From File and you can drag and drop the file and you can give a name to that file. And you can just select the default compiler that is sufficient for the use case. So you can just do that. So once you're done with that, you can click on Create button and it should create the notebook for you. It should load the notebook for you. So yeah, Khalil, could you open the notebook back again, which you have uploaded? So yeah, once you come to this page, when you upload the notebook, it might load in this way. So you need to click on the edit button. So you're able to edit the button. You're able to edit the notebook. So once you come over here, you would wait for the notebook to load. So we'll give it a few seconds. So once you come to this page, you'll see 4 sections. There's a table of contents. So now what we'll do is I'll start explaining the sections of the notebook and we'll understand how the notebook works. So first thing is, what is language modeling? So language modeling is the use of various statistical and probabilistic techniques to determine the probability of a given sequence of words occurring in a sentence. Language models analyze bodies of text data to provide a basis for their word prediction. So this is used in natural language processing applications, particularly ones that generate text as an output. So some of these applications include machine translation and question answering bots. So how language modeling works? So as you can see on the screen, you have this context, you have the words, and then you have the probability assigned to these words. And you see the one with the highest probability, which relates to this sentence, will come next. So it's trying to assign these words depending on the most probable situation this word is used in this context, and then try to create sentences. This is what language modeling is. It's try to analyze text data and then generate text data also. So as language models determine the word probability by analyzing text data, they interpret this data by feeding it through an algorithm. And in our case, the algorithm is a recurrent neural network, and this establishes rules for context in natural language. The model then applies these rules in language tasks to accurately predict or produce new sentences. The model essentially learns the features and characteristics of a basic language and uses those features to understand new phrases. There are several different probabilistic approaches to modeling language. This vary depending on the purpose of the language model. So speaking from a technical perspective, the various types differ by the amount of text data they analyze and the math they use it to analyze. So for example, a language model designed to generate sentences for an automated Twitter bot may use different math and analyze text data in a different way than a language model designed for determining the likelihood of a search query. So there comes some common statistical language modeling types. They are n-gram, unigram, bidirectional, exponential, and continuous space. So I'll just give you a brief overview of each of these types and how they approach. So
N-grams are relatively simple approach to language models. So they create a probability distribution for a sequence of n. And the n can be any number that defines the size of the gram or a sequence of words being assigned a probability. For example, if n is equal to 5, a gram might look like this. Can you please call me? Suppose let's take an example. Can you please call me? And the model then assigns the probabilities using sequences of n size. So basically, n can be thought of as an amount of the context the model is told to consider. So some types of n-grams are unigrams, bigrams, trigrams, and so on and so forth. So we'll just be going over through unigram. So unigram is the simplest type of language model. It does not look at any conditioning context in its calculations. So it evaluates each word or term independently. And unigram models commonly handle language processing tasks, such as information retrieval. The unigram is the foundation of a more specific model variant called the query likelihood model. And this uses information retrieval to examine a pool of documents and match the most relevant one to a specific query. Next, we have the bidirectional one. So unlike n-grams, which analyze text in one direction, backwards, bidirectional model analyzes text in both directions, backwards and forwards. This models can predict any word in a sentence or a body of text by using every other word in the text. So examining the text bidirectionally increases the result accuracy. And this type is often utilized in machine learning and speech generation applications. So for example, even Google search uses bidirectional model to process search queries. And this is what we're using for our approach today, for our use case today. We're also using a bidirectional approach. Now, there's something called exponential. So this is known as a maximum entropy models. So this type is more complex than the n-grams. Simply put, the model evaluates text using an equation and then combines feature functions and n-grams. This type specifies features and parameters of the desired results, unlike n-gram, and leaves analysis parameters more ambiguous. It doesn't specify individual gram sizes, for example. So this model is based on the principle of entropy, states that the probability distribution with the most entropy is the best choice. In other words, the model with the most chaos and least room for assumptions is the most accurate. Exponential models are designed to maximize cross entropy, which minimizes the amount statistical assumptions that can be made. And this enables users to trust the results better they get from these models. So if you're going towards a more complex kind of a text analysis model, then you're trying to approach these kind of models like exponential, because these are as they're known as maximum entropy models, and they try to relate to the probability distribution with the most entropy. So the one with the most chaos and least room for assumptions is the best choice. This is how this model works on. This is the principle of the model. And lastly, we have the continuous space. So this type of model represents word as a non-linear combination of weights in a neural network. So the process of assigning a weight to a word is also known as word embedding. And this type becomes especially useful as data sets gets increasingly large. And because larger data sets often include more unique words, the presence of a lot of unique or rarely used words can cause problems for linear models like n-gram. And this is because the amount of possible word sequences increases and the patterns that inform results become weaker. So by weighing words in a nonlinear distributed manner, this model can learn to approximate words, and therefore it is not being misled by any unknown values. Its understanding of a given word is not as tightly limited to the immediate surrounding words as it is in n-gram models. So next, we go towards the next section. That is the Khalil, could you scroll a bit down? So the Treebank data set. So what Khalil has explained what is the Penn Treebank data set. So I'll just try to recap. So if it is a data set maintained by University of Pennsylvania. It is huge, and there are over 4,800,000 annotated words in it, all collected by humans. This data set is divided in different kinds of annotations, such as piece of speech, semantic skeletons. And for example, we'll simply use some sample of clean and non-annotated words, so that our use case is very simple, and we're trying to understand how neural network works on this case. Next, we have what are word embeddings. So, word embedding is just a learned representation for text where words that have the same meaning have a similar representation. So, it is this approach to representing words in documents that will be considered one of the key breakthrough of deep learning on a challenging natural language processing problems. So, word embeddings are in fact a class of techniques where individual words are represented as real valued vectors in a predefined vector space. That is, each word is mapped to one vector, and the vector values are learned in a way that resembles a neural network. Hence, the technique is often lumped into a field of deep learning. So, it itself is considered almost as as good as a field of deep learning because of how complex the matrices can get with your words by embedding your words with vectors. The key to approach for this type of model is the idea of using a dense distributed representation of for each word. So as you can see on your screen, there's a diagram. So it's trying to encapsulate, words that are more related to each other, like, economy related, country related, or number related. So it tries to group words accordingly, and then it tries to also create vectors for each of these words. So that, each word, depending on the context, it tries to, frame the sentences. So this distributed representation is learned based on the usage of words. This allows words that are used in similar ways to result in having similar representations. And this therefore tries to naturally capture the meaning. This can be contrasted with the crisp but fragile representation in a bag of words model, where unless explicitly managed, different words have different representations, regardless of how they're used. So there's a deeper linguistic theory behind the approach that is called distributional hypothesis, which summarizes that the words that have similar context will have similar meanings. So there are various algorithms in this also. You have the embedding layer, the word2vec, and glowvec. So depending on what approach, you can select these algorithms and you can go ahead. So this is about word embedding. So let's proceed to the next section towards the long short-term memory. So now what we're trying to do is we're trying to build our recurrent neural network using the long short-term memory model for text classification in Python. So Khalil has explained, what is long short-term memory, but I'll try to, recap, and I'll try to add something to it, which will be utilized today for our use case. So long short-term memory stands for, LSTM stands for long short-term memory, and it is type of a recurrent neural network, but it is better than the traditional recurrent neural networks in terms of memory. So having a good hold over memorizing certain patterns, LSTMs perform fairly better. So as with every other neural network, LSTM have multiple hidden layers, and as it passes through every layer, the relevant information is kept and all the irrelevant information gets discarded in every single cell. And how it works is that it has three main gates. One is the forget gate, the second is the input gate, and third is the output gate. So the forget gate is responsible for deciding which information is kept for calculating the cell state and which is not relevant and can be discarded. So the information from the previous states, it gets discarded, which is relevant is kept, and it's whichever is not relevant is discarded. So this is then passed on through the functions and to the this information is again with the relevant information is passed to the next state and the next layers. Next, we have the input gate. So this updates the cell state and decides which information is important and which is not again. So as the forget gate helps to discard the information, the input gate helps to find out important information and store certain data in the memory that is relevant. And then the inputs are all passed through again functions respectively. So it goes to the various it's again this information is passed through again different layers. Then lastly, we have the output gate. So the last gate, which is the output gate, decides which is the next hidden state. And this again, then it passes on to the sigmoid function. Then the newly modified cell states are passed to the functions, and it is multiplied with the sigmoid output to determine what information the hidden state should carry. So again, keep reiterating and keep learning from itself. It tries to keep the relevant information and keeps discarding the irrelevant information. So again, sometimes what happens is irrelevant information which is assumed to be relevant can be useful later. So that's why we go for a long short-term memory model, because traditional neural networks suffer from short-term memory. And also a big drawback is the vanishing gradient problem. So while the backpropagation, the gradient becomes so small that it tends to zero, and such a neuron is of no use for further processing. LSTMs efficiently improves the performance by memorizing the relevant information, and it is important. And it tries to find patterns from this. So LSTMs are used for text classification. There are multiple algorithms like decision tree, a random forest, and support vector machine that can do a fairly good job. But we still LSTM is the most preferred one. One good reason to do so is it is more effective in memorizing important information. So if you look at other non-neural network classification techniques, they're all trained on multiple words as separate inputs that are just words and having no actual meaning as a sentence. And while predicting the class will give the output according to the statistics, not according to the meaning. This means that every single word has to be classified into one of those categories. But but in LSTM, that is not the case. It tries to understand the meaning of those words and then it tries to group them together depending on the meaning, not on the probability, not on the classification. According to the statistics, it's more on the meaning than the statistics. So as you can see, the notebook here, if you load the various you install the TensorFlow and the NumPy libraries, and then you keep going, keep updating these libraries in various libraries. So you install these libraries, and then if you scroll down a bit down, Khalil, could you scroll a bit down? You install these libraries, and then you go to download dataset option in the section. So once you go over here, you install the dataset. You try to link the dataset to this notebook, and as it's a vast dataset, you can just don't need to download it. You can just link it using the hyperlink. And what we have done in this case, and you can just refer to the dataset from here. So it's form of a TGZ file, and you can just go ahead and you can refer to this. Now this is where we're constructing the neural network. So we'll have various steps. So the first step is initialization. So this is where we initialize the weights and the various hyperparameters, the epochs. So there are three steps different ways you could do this. So one is you assign all the parameters as 0. That the next thing is when you run, and then you decide on some random values. So depending on the activation function, you can run these values, give the parameters the values which have been most, or which have the most probability to give the better result. So then you go assign some random variables. And then lastly, there's this Javier initialization where you assign random variables in an interval form. So that is -1 by root n to 1 by root n, and n is the number of incoming connections. So then you assign, you create your function for the forward propagation. So the function of forward propagation is to traverse to the end. So then you create those functions over here, and you assign the states, the new state, the old state, the input vector, and you define the function with all these parameters. So this is all is done over here, and you also define the batch size, the epochs. It's trying to go over through, and the iterations it has to go through in each epoch. Khalil, could you scroll a bit down? 1 second, my screen is taking a bit of time to load, so I'll just give it a few seconds. So now we go ahead and we try to define train our data. So under when we are trying to train our data, so we have the actual data set that we use to train the model. So we kind of split this into two sections. So we have the training the data set, then we're validating the data set, and then we're trying to test this data set. So what happens is we need to split this data set into a ratio where it goes for testing and training and testing. So this depends on the split depends on two things. Firstly, the total number of samples in your data, and second, on the actual model you're training. So models with very few hyperparameters will be easy to validate and tune. So you can probably reduce the size of your validation set. But if your model has many hyperparameters and you want to have a large validation set as well, then you should also consider cross validation. So you have to happen to have a model with no hyperparameters or that cannot be easily tuned. You probably don't need a validation set too. So depending on the use case, you have to split. If you want to validate, if you have a lot of hyperparameters. In our case, we have a lot of hyperparameters. So we need to have a large training. We need to keep the ratio in such a way that it has more training data. It needs to have a vast amount of training data. And then once we're done, we input the data, we go to the we have the shape of the data which we're training, and once you go through this, we go to the embeddings. Once we are selecting, we have done with the with our selecting a train data, and once so I'm just once again, my screen is stuck, so I'm just waiting for it to load. So now the training data set needs to be converted into vectors of numbers. So this is a traditional approach to using one-hot encoding method, and this is often used for converting categorical values to numerical values. And as one-hot encoded vectors are high-dimensional and sparse, they're computationally ineffective. So we use the word-to-vec approach, and we try to in fact add a layer to our LSTM network, and these IDs and word IDs are represented by a dense representation before feeding to the LSTM. Now the embedding layer finds the embedded values for the entire batch, and it goes to the input data, that is our training data, and it goes to each word in each row and sentence, and then tries to find the corresponding vector for this. So it goes, it finds all this, and then we proceed to constructing a neural network. The next step of a constructing neural network. So now we have the LSTM cells, and we are trying to initialize the states. So once we go with initializing the states, as I mentioned earlier, we go to the other steps, like these calculating the loss function we need to define. You define the stochastic gradient descent, and the back propagation through time, and even the forward propagation. So we have these various functions we are going to work on this. So finding the loss is an important stage in training the loss function, and it determines the state at which the model is. So it tries to help you determine which your state at your model is, so that you can always save the data, and you can see what's the progress so far. So this is why we require a loss function, so it keeps storing the state of a data, and also it keeps a track of that, and tries to minimize the loss function. That is, tries to reduce the loss of data over here. Then we have the stochastic gradient descent. So it is a popular way of optimizing your model. So it is a way in which you send inputs in batches instead of the whole input, and this way you can easily scale your model. So you break your data into a chunks of small data sets, and then you try to input your neural network through this. So what happens is, it keeps training this over this batch of data, and it keeps improving its accuracy, and it keeps optimizing your model. And it's easier for you to scale your model this way. And then we have we go through the back propagation. We have the activation layer and the dense layer. So it is a technique where you traverse again back to the start, and you will update your weights based on the optimizer results. So you go ahead, for this you have the dense layer, and you have the activation layer. So dense layer is a neural network layer that is connected deeply, and which means each neuron in dense layer receives input from all neurons of its previous layer. And the dense layer is found to be most commonly used layer in the models. So the dense layer performs a matrix vector multiplication, and the values used in this matrix are actually parameters that can be trained and updated with the help of backpropagation. And the output generated by the dense layer is an m-dimensional vector, and dense layer is basically used for changing the dimension of vectors, and it applies these operations like rotating, scaling, and translation to modify the dimensions of the vector. And then once you're done with this, and you go on try to predict this thing, so you try to define your train your data set. So can you scroll a bit down? So you go on training, and then as I mentioned, you have the optimizer. So you define your optimizer, and then you assemble all the layers to build the model. So whichever functions you've defined so far, which I mentioned, you're going to assemble them together. And once you're done with that, you try to train your model. So you go a bit down, and you try to create a class for your LSTM, long short-term memory model. So you go over this, you try to create a model in accordance with your predefined parameters, and then you also need to create a cell structure and link them to your RNN structure. And then whatever word embeddings we had done earlier, we point them to the input data. And then we try to create an input structure for an recurrent neural for our RNN. And then we also apply a logistic structure to return the probability of our words. So we need to create a loss and cost functions, as I mentioned, for optimizer to work, and then create the optimizer. And finally, we need to create a training operation that can be run to actually train a model. So if you scroll, Khalil, if you scroll a bit down, so you come to section 5. And yeah, so this is where you start by training, you're testing your data. So all the hyperparameters you have defined and all the epochs you have set. So right now we had so in this case I have one example where I've run 5 epochs. In this case there are 15 epochs. So you can see the difference in the number of epochs. So once Khalil, could you open the next notebook, the notebook which is the results? This is not the one, the other one. Yeah, and can you scroll down section 5? Yeah, screen stuck actually. So yeah. So yeah, can you scroll a bit more down? Slightly more. Yeah. So over here you can see number of epochs and the results generated by each of these epochs. So after epoch 1, you see the train perplexity as 360.071, and then after epoch 2 it comes down to 165, and in epoch 3 it comes down to 126, and in the 4th epoch it goes to 106, and the 5th epoch it goes to 93. Now you see the perplexity is decreasing, and because the more the number of with each epoch it's being trained and it's been able to evaluate these results, and then it's able to send it's to be able to back propagate and reverse engineer its way, and tries to change the weight so that you get the most favorable output or most preferred output. So it's kind of a manner of reverse engineering, and it tries to figure out. So it lowers the perplexity, and perplexity means that the model is more certain about its prediction. As the perplexity decreases, the model becomes more and more certain about its prediction, and as we increase the number of epochs, so if you have more number of epochs, it could go down to even 52, the train perplexity. That means our model is becoming more and more certain about it, and this would take more time for the model to train, but the results would be more favorable, and that means our model has become more and more certain about it. So this is the output by running the notebook, and that brings us to the end of the hands-on session. Now I'd like to pass on to Khalil to conclude the session.
Yes, thank you, Mridul. Let me just share my camera again. Okay, so just to make a thank you, Mridul, for all the explanation. And guys, I know maybe there was a bit of lagging. We apologize for that, but I had to share what Mridul was saying from my screen for some of the technical issues that we're facing. So again, I just apologize. We apologize on that. Just double check. Am I okay? I'm on mute. So we just want to make a quick summary on what we exactly did. So we were able to see how we can build an LSTM model for a language modeling use case using the Penn Treebank dataset. Mridul as well explained what are words embedding, and he showed how we can train, validate, and test the model itself. So this was kind of a brief introduction to how we can work with LSTM using Watson Studio and using TensorFlow. Of course, we had to show you how the results are because, as Mridul said, it can take a couple of hours to actually generate this. So if you're free, you can, of course, do it on your own, and you already have the link for the results. So you can compare exactly the one that we have with the one that you're currently working on. And you can always reach out for any questions. So these are some couple of useful links that I want to share with you. So the first one is obviously the IBM Cloud account where you can sign in and sign up. Then we have the hands-on lab that Mridul was explaining. Another very useful link is IBM Developer. So basically, this is kind of a portal where you can learn everything you want. We are covering all kinds of technologies, security, microservices, data and AI, and many, many more. You will see a lot of tutorials, articles, code patterns, so you can just go ahead, check what you want, and start increasing your skills on what you want to learn. And finally, we have the meetup link. You can go ahead and check our events if you want to follow more of what we're doing. You can always just check there. Feel free to join any event that you're interested in. And just a couple, speaking of useful links, I just want to show, I believe we have some links here in case you want to go a bit more into recurrent neural networks and deep learning. I'm not sure. Mridul, do we have the links for the tutorials. This one, deep learning and recurrent neural networks. Are they
Yes,
added in
it's
the-
all in the hands-on guide. If you click on the hands-on guide, you can be able to rewrite to the tutorial. Yeah.
A hands-on guide. Yeah, okay, great. So if you go to the hands-on guide, we will be able to go ahead and see how you can build a recurrent neural network using TensorFlow, Keras. So this basically will redirect us again to the tutorial, so we can follow along with that. So basically that's it. Let's go back. For people who are participating on Call for Code, we just want to make sure that you submit. In case you didn't submit your solution there, there is still time to submit it. We will share the link on Crowdcast right now in the chat. So in case you want to chat, and you can always feel free to join us on our Slack channel for any further questions. But again, this is only for people. Anyone can join, of course, the Slack channel, but the submission is only for people who have already come up with a solution regarding this event. And basically, that's it. We want to thank you for attending this session. These are our contact information. I'm sure as well Brito is sharing them on the chat. And please make sure to fill out the survey, which has just a couple of questions. That will take no more than 1 minute. This will help us to improve and as well to learn from you what you're interested in the future, what kind of topics would you like to learn more about. So that's it for this session. We want to thank you all, and feel free to ask any questions if you have.
So I see a question in the chat that says there's a question regarding use WhatsApp. I think so from what we understand, I think WhatsApp doesn't use it for user specific. It does it globally, and it tries to recommend based of that. So that's how I think the privacy issue started, and it's basically trying to analyze all the data from all the users combined. So it does it globally. It doesn't use it for user specific. It does it in common for everything. That's how the the network or the model works for WhatsApp, because it would be too I think it would be too cost draining and time draining for them to do it for each user, because there are billions of users for WhatsApp. So it kind of does it in common, and then it tries to recommend on the most common sentences, and it tries to recommend those words.
So any more questions? By the way, guys, this session is recorded. So if you go to the same link, you'll be able to watch the entire thing all over again. If you have some more things that you're not able to catch up, you can always feel free to watch using the same Crowdcast link and watch the entire thing all over again. So this is just a quick note to put it there. So I think if we have no more questions, then we can end this session. Thank you, Anderson. Thank you for the feedback. All right, then. Thank you, everyone. We hope this was something very interesting for you and something useful. If no more questions, then I think we are good to go.